Dear students, I welcome all for this practical session. In this session, we are going to implement the next lab cycle program, that is a program to evaluate postfix expression. So in our theoretical session, we have discussed how to evaluate the postfix expression using stack data structure. Now we are implementing the same thing in C language. So we will begin with including preprocessor directories, that is hash include stdio.h, then hash include conio.h. Next, I'll declare a stack of float type. So this stack is going to store the operands. I'll declare the stack size as 50. And next I'll declare an array to store a postfix expression. So an array of character type postfix, which is of size 50. So this postfix array stores postfix expression. Why this is of character type? Because the postfix expression consists of operands and operators. So all operands and operators are considered as character. Hence, I am storing it in character array. Next, I'll declare integer variable I to keep track of every character in the postfix expression. And then I'll declare one more variable called length to store the length of this postfix expression. Okay, and then I'll declare one more variable to keep track of the stack, that is top variable, initially with the value -1. Okay, and now we are going to begin with main method, void main. So within void main, I'll declare clr clear screen function. And in the next line, I'll prompt the user to enter postfix expression. Enter postfix expression /n semicolon. Then I'll read that postfix expression to this postfix array, scanf %s, comma, postfix. Although this postfix is an array, we are not using any looping statement. This %s is nothing but a sequence of character. It reads sequence of character, the whole string. Okay. Hence, you need not place this postfix array within the for loop. Okay. Just write the name of the array. To this array, the entire characters inputted by the user will be read and it is stored. Next, after reading the postfix expression, what is the first step in evaluating postfix expression? We need to scan each symbol, right? So to scan each symbol, first I should know the length of the postfix expression. So I'm computing the length of the postfix expression by calling string length function. So string strlen of postfix. Since I am using this strlen method, I'll be including an header file hash include ctype.h and hash include string.h header files. Okay. So now I computed the length of the postfix expression. In the next line, I'm going to scan every symbol of this postfix expression. So I'll use a looping statement for I equals to 0, I less than length, I plus plus. Okay. And now I'm going to read the symbol. So I'll declare a character variable called sim. So the next symbol in the postfix expression, symbol equals to postfix of ith symbol. Okay, postfix of I. So after scanning the symbol, in the next line, you are going to check whether that symbol is an operator or an operand. If it is an operand, you are going to push it onto the stack, right? So you are going to check the symbol. If the symbol is a function, is a string function, which is going to check whether the symbol is a digit or not. So if it is a digit, this if condition becomes true. In this case, you are going to push the symbol to the stack. Okay, so you're going to push the symbol to the stack. I'm calling a push function. Later, we are going to define the body for the push function. So I'll write push symbol. Yes, I am. See, here the sim is a character type, but the stack that to which we are going to push this symbol is a float type. So that means this character cannot fit in this stack data structure. Okay, so you have to convert that to digit and then you have to push it onto the stack. For that, you will write sim minus 0. So this is automatically going to convert the digit, which is a character type, to float type. Okay, and then it will be stored onto the stack. Next, if condition closes, next comes the else case. So if the symbol that is scanned is not a digit, then obviously it is an operator. So if it is an operator, you are going to pop two operands from the stack. So the first operand that you are going to pop will be the second operand to the operator. And the second operand you are going to pop will be the first operator to the first operand to the operator. So I mean the first operand that you are going to pop from the stack will be your N2. I'll declare two variables of float type N1, N2, num1 and num2. Okay. So now the first operand that is popped from the stack will be my N2 and the second operand that I pop will be my N1. And now we are going to perform the operation. So how we are going to choose the operation? Depending on the operator, right? So I'll use a switch case to check which operation has to be carried out on N1 and N2. So if the case is plus, then I'll write push. If the case is plus, I'll write N1 plus N2, which is nothing but the sum of two numbers. After computing the sum of two numbers, the result is again pushed back onto the stack, right? So I'll write push N1 within parenthesis N1 plus N2. The sum of N1 and N2 is computed and the result is pushed onto the stack. Next, break. Okay. After this plus operation, we are going to check whether the symbol is minus. If the symbol that is scanned is minus, we are going to write N1 minus N2. Then semicolon, break. Next case is star. If it is star, again, you will write push N1 into N2, then break. Next, last case, that is division. You are checking whether the symbol scanned is division operator. If the symbol scanned is division operator, you are going to perform division and the result is again pushed onto the stack, N1 divided by N2. Then break. Okay. So now all the cases are over. So if the scanned symbol is none of these operator, then obviously you're going to print a message that comes under default case. So default case printf invalid operator or invalid symbol /n. Okay, then bracket close. Then the default case is over. Then you're going to close the else case, and then the for case. So after closing the for loop, so if all the symbols are scanned in the postfix expression, then at the end you are going to perform pop operation. So once you perform pop operation, the popped item will be the result of that postfix expression. So I'll write after for loop, I'll write printf. The result is percentage f /n, comma, comma, pop. So this pop function at the end will give you the resultant of the result of the given postfix expression. And next, get ch, then main method close. Okay, I hope I have followed the braces. I have closed and opened the braces properly. So for loop close and then void main close. Now we have to write the body for uh, push function and pop function. So now let us start defining the body for push. So push, this function is going to accept a parameter, which is an input, an item, which needs to be pushed onto the stack. Okay, so while pushing an item onto the stack, you are going to check a condition whether the stack is full or not. How do you check? If the top value is not equal to maximum size minus 1. If it is not equal to top is not equal to maximum size minus 1, then the stack is not full. In this case, you can push an item onto the stack. So you're going to increment the top pointer, and then to stack of top position, you're going to assign an item. This closes if, and then comes the else block. If the top is equal to maximum size minus 1, then the stack is full. Then you're going to print a message, stack is full /n. Next else close, and then push function finishes. Next, you're going to define pop function. Pop does not accept any parameter, but it is going to return a value. So the return value will be a float type. Hence, I'll write float pop. The next line, you will write, you are going to check a condition. If the top of the stack is equal to -1, then the stack is empty. There are no elements to pop. Okay, so you are going to print a message, printf stack is empty /n. Else you are going to pop an item. So else you will write return stack of top, and then after returning the stack top, you are going to decrement the top pointer to indicate that element is deleted. Okay, so top minus minus, then semicolon, then else block close, and then pop function closes. Okay, so this completes the program. And now we will compile the program for any errors. So the function push should have a prototype. Okay, so we will define a prototype for the functions. So for the push, it is void push. Within the bracket, it is going to accept one parameter float type, and then float pop, it is not going to accept any parameter. So I have defined what prototype for the functions. And next, there is a type mismatch in declaration of push. Okay, I have to define void. And now I'll compile. There is one error. So max size variable is not defined. So I have to define this variable with the value 50. So I'll declare it as integer type, max size equals to 50. Okay. So I hope all the errors are going to vanish. So there is one error, but don't worry about that this warning message. Only you have to worry about the error messages, not about the warning. And now I'm going to execute the program. I'll give a postfix expression A, B plus, sorry, I'll give an expression 4, 5 plus. So what is 4, 5? 4 plus 5, it is 9. Okay, let me give one more input for this program, a lengthy expression. Okay, I'll input 2, 3, 4 plus, uh, plus, sorry, star plus 4 minus. Let us check what is the output. So first 3 and 4 is multiplied. So you will get 3 fours are 12. 12 is added with 2. You will get 14. 14 minus 4 is 10. So it is giving the correct answer. Okay. So when this postfix expression 2, 3, 4 star plus 4 minus is evaluated, you will get the answer 10. So this completes the program. You can try by giving different inputs for this program. Okay, and you can manually verify whether the output that you have got is correct or not. Thank you for your patience listening.